Hi to everyone. It's not a good moment to forget the password of your computer, so I was thinking the next 5 steps, oh wait, is it my mom's birthday, my birthday? Who is my mom, who am I? Where should I ask ChatGTP? Okay, so thank you very much. My name is Sven Maričić. Together with my student Dominik, I will present you some of the results that we did achieve. And before that, dear Timo, Marina and I can speak with you a bit in Swedish and in Norwegian language. So we are still not robots, so maybe we can have a cup of coffee with all three. I was always wondering whether am I acting as a scientist or as a person who is also dealing and struggling every day with lots of problems. And maybe that determines me, not problems, but everyday challenges. I prefer to say challenges. In morning sessions, they said lots about AI, artificial intelligence, lots about ChatGTP. So I will just say that lots of new information also for me was told in morning sessions, and I'm going to present you hands-on experience from the laboratory. What are we actually doing as a scientist? And we, of course, are trying to realize our ideas because we are living in a society that is actually try to think of ourselves as humans who are actually advanced. But is technology so advanced that we cannot resolve some of the very interesting questions, such as how can I do something, or how can I transfer myself from point A to point B, or there are something that is actually universal. Robotic arms, combined with AI, of course, I think are presenting enough challenge, and I will show you today some of the results where we succeed to apply from CAE, computer-aided engineering, to additive manufacturing, a bit of CNC machining, and of course some parts of educational production of robotic arm with 3 degrees of freedom, DOF in English abbreviation. That was the first step, actually. When I mention robotic arm, you're always thinking about some RoboCop who will cut or chop off your head or something. But for me, as technology enthusiast, I'm always thinking what possible functions could have those robotic arms. So maybe it can take care of your children, to take care of cradle of your babies. Maybe it can bring glass of water to your old grandmama or grandfather. Maybe it can do lots of interesting stuff and help you if you are a deaf person and you need to learn the sign language. Together with my students, Faculty of Medicine, we developed one small application, and the program itself can recognize first 4 letters of sign language. And that's something that is very important. Why are you so serious? Okay, that's much better. Someone mentioned that everything in life should be play, and humanoids are actually much better to learn and to comprehend something if we are playing. So let this event and day will be one of the nice games that we can play in order to learn something new. The main motivation of dealing with robotic arms was that we would like to achieve and to decrease some of the used materials inside. We did also analyze of structural elements, and with help of generative design, which is based on AI tools, we did one remarkable thing, which is 20% less of material and 15% less of time production from this initial 3D model. The next one was actually where we are going to implement it. So one of the first ideas was standard ABB, which stands for ASEA Brown Boveri, very famous manufacturer of robotic arms. And we said maybe we can try to make end effector for 4, 5, 6 degrees of freedom equipment, and therefore we decided to try our best and to see which type of technologies actually we can use. So we decided to use 2 types of technologies. First was cutting of aluminium materials. And second one was, of course, as I mentioned previously, 3D printing slash additive manufacturing. From aluminium material, we did first type of optimization, and it was pretty straightforward. We were very satisfied with the results, and of course, we then proceed to do next thing. Next thing was a bit more complicated. Why? Because when we are struggling with three-dimensional things, we need to take into account several outcomes, several series, such as forces, payloads, moments of inertia, etc., etc. Okay, now it's boring, so you can be serious. Then I will stop. No more ice-breaking jokes for you. And then we decided to go one iteration over another, and then after 100 of generations, we got this type of solution. For today's presentation, for today's lecturing, I brought also a live model, so I'll be also very happy to show you how it looks like in silico, not live. I mean that in silico, in live, in my computer is living at the moment. But we also did 3D printing of the whole model. So one part of the studying has been presented here. I'll be more than happy to answer all possible questions, and maybe later we can also discuss something in English, of course. My Swedish is also not so good. What was also here important, actually, that for the grip part, we also took one very basic element which was not too complicated for us, and then we tried to make it even decrease the amount of time which need to be produced, and to see how many strategies of producing and manufacturing can be actually used to produce this part. So we use actually TPU material, additive, and that's more or less regarding the setup requirements. That was the final version, final 3D model. And as you can see, the things that I'm showing here now are actually got by help of AI. So that's the aim of optimization. How do you like it? Hoping that... Wow, cool. Oh, wait. Thank you very much. And a few slides more, and then I will show you the model in real life, how we did it actually in production. So we try to work with the materials who are at the market. In next iteration, continuation of the project will be to take into consideration environment materials as well, such as different type of polymers that are more eco than this one. And we are also thinking, if we will do robotics for children, for kids, that we will collect all the bottles and try to make from that type of polymer material and effector of robotic arms. So imagine if you can collect 100 bottles, and in that way you can donate to kindergarten in your own city, in your town. You know, that's one of the ideas that we would like also to include. That's also one part during the production time. Material was TPU, flex, gray, standard material, and SLS technology. You know that nowadays there are very broad materials that are being bring to the market, from different type of polymers to aluminium alloys to titanium alloys that are being using also in biomedical field. And of course, the only question is actually the importance of time, of money, of course, and the quality of finished surface. That's also very, very important. Assembly, which actually passed very smoothly. So it was very straightforward, and it's working out of the box, as we prefer to say. Now it's my great pleasure to show you here the arm. Okay, yes, I need to exit. Sorry, I cannot see it, but you cannot. Okay. Okay, much better. So, in this program solution, we can actually try to analyze the robotic arm movements. We can rotate, zoom, pan. We can even do the inspect of construction sections, and we can then also make further optimization towards our project, of course, aims. What is most important here is that in every step of this project, in every step of that part, we can also take into account different suggestions, and you can count that in next 3 to 5 months we will also have a new version, and then we will start to investigate whether it can be produced from the bottles of water actually that we'll be collecting all around. So unfortunately, I'm flying with Ryanair and I have just 10 kilos of baggage with me, so I cannot collect, I cannot start to collect the bottles. So drink your water, refresh yourself, and next year we will start to collect the bottles. I mean, it's real thing, you know, Ryanair 10 kilos, otherwise you need to pay 20 euros more. Okay, and for conclusion, I need to say that what we achieved here was 2 or 3 things. First at all, it was aimed for educational purposes. Second, the procedure that has been done and the research, conducted research, actually resulted in optimized model from 15 to 20% less of materials and around 10% less time. Of course, the numbers are always numbers. Why? Because we developed several models, so with different sizes and with different approach. This model that I'm presenting at the moment was our latest model, and we are very satisfied with this model, and we are thinking that the further inspection and analysis will be also conducted here. Once more, thank you very much for your attention. Aitäh, tack så mycket. Tusen tack. My name is Sven Maričić. Thank you.
Aitäh, Sven. Just one question. What kind of potential do you see for this technology in the future?
Yes, it has huge potential, especially in educational format. Why? Because maybe you can bring your own Lego devices, Lego setup of this one, because at the moment it cannot be assembled just like this. You need to have Phillips screwdrivers, etc., etc. But one of ideas is, since you mentioned that, maybe it could be also produced in a way that we can assemble it like a Lego form, and that's one of the possibilities as well.
Excellent. Thank you so much, Sven. We have to continue with the program.